This is TechSNAP, episode 355. Welcome to TechSNAP, Jupiter Broadcasting's weekly systems network and administration podcast. We recorded this episode on February 6th, 2018. This episode is brought to you by our three fine sponsors, IX Systems, Ting, and DigitalOcean. My name is Chris, and joining us every single week is the sysadmin, the DevOps, and the presenter, all in one package. It's Mr. Payne, Mr. Wes Payne. Hello, Wes.
Hello, Chris.
Well, our warm-up story for this week seems to be one that's all of the rage, breaking into people's boxes and mining crypto coin. And the most popular one these days seems to be Monero, although the devices that were targeted in this attack might not be the ones you'd first expect.
Yes, over the past weekend, a fast-moving botnet has appeared, and it's infected thousands of Android devices just in that short time frame. This is previously unseen malware, and of course, it's got great worm-like capabilities, so really there's like no user interaction that's required. It just hops around, you have a vulnerable Android device, it's there.
This isn't the first crypto coin that we've seen going after Android devices. In fact, there was a story in previous TechSNAP history that we covered where mining crypto on these Android devices was actually destroying them. It was like running them into the ground. This one, though, is a little different because in the past, they had to slip it in through like an APK sideloading. I don't think this is using sideloading.
No, this looks to be abusing devices that have Internet port 5555 open. Now, port 5555, as you probably know, is normally closed, but if you've been using ADB, also known as the Android debug bridge, it may be left open.
So this is going after devices that have specifically enabled this debug mode.
That's what it appears right now, but it's all very fast moving. The company behind some of this research, NetLab, they saw 2,750 unique IPs just in the first 24 hours. So it's moving fast, and I don't think researchers have really completed all of the, understanding completely what's going on.
It sounds like, too, I did a little digging before the show, for some reason, and I don't understand why, a lot of devices in China are sold with some of these debugging stuff turned on. I don't know if it's just what the market expects over there. I didn't go that far into it, but it seems like the Chinese market is more vulnerable to this attack because more of those devices have this stuff turned on.
Yeah, oftentimes there's that last level of QA that doesn't get done. Of course, when you're trying to develop one of these devices, you need to be using the debug bridge, right? That's part of the development process to interface, upload new code, etc. If you don't properly secure that before selling it to the customer, this is exactly what can happen.
What's interesting here, too, is it seems to be affecting Android television set-top boxes, which in some cases are a little more powerful than you might have in your pocket because they've got an always-on power line, so they can run those CPUs and those GPUs at full power because they don't have to worry about the battery life. And I wonder if that makes them more profitable for like Monero miners.
Right, and you're a little less concerned, right? As long as whatever you're trying to watch plays, you're not feeling your phone overheat in your pocket. You're not, how often have you paid attention to any of your TV devices? I'm going to bet never.
It's in a closed cupboard, to be honest with you.
Exactly.
Yeah, as long as it's playing the video. It doesn't even have a fan, I don't think, so I don't even think I'd hear it.
So it really seems like another one of those cases where unless you're a really responsible admin, you have separate networks and careful firewall policies, this could happen to anyone.
Now, it's not like we're talking about a ton of hash power here. They're using their own mining pool for this malware. So you can actually look at the hash rate of the mining pool. And a couple of days ago, it was around 7,800 hashes per hour. So at the time of checking for research from this show, they had mined about $5.
Oh boy, that's worth your time. That is kind of one of the fun aspects of a lot of these blockchain cryptocurrency attacks is that a lot of the information's out there in the public just to be pruned.
Yeah, it's fascinating because it gives you a real sense of what are they getting in return? Is it really just for fun? Is it they're hedging? If you had done this, if you had mined this Bitcoin, when Bitcoin was still capable of mining on the CPU back in 2011 and held on to it, you'd have quite a bit more money right now. So there's not just the immediate value, but there's also the value for these essentially hoarders. They could be compromising people's systems and then hoarding the results and hoping for payoff down the road.
So are you saying that script kiddies are wise to investing now?
Maybe. It could be. That or maybe they're just spending it on pizza. Since the reboot here of the TechSNAP program, we've been covering some of the fundamentals, so that way we have reference points in future episodes to send people back to. And this week we thought we'd cover some best practices for user account management, authorization on your network, and password management. If you're managing a local network or online services, this is going to be applicable to you. If you're Windows, Linux, or BSD, or Mac, this will also be applicable to you. It's just essential best practices.
Now, this is over at Google Cloud's blog, but I think there's a lot of takeaway here for really anyone.
Yeah, we're going to put our TechSNAP spin on this and use some of our own experience to kind of, I think, pad this out and maybe smooth over a few parts that are a little too Google specific for us.
So let's start first up, and we've talked about this a lot, but it remains really important. Hash those passwords. It's the most important rule for account management. You need to safely store sensitive user information, including their password, right? You may think the password is just some random thing to get access, but it controls so much. And people have so much personal information stored, especially if you are a big service like Google, but even if it's just, your local neighborhood group.
This is really a message to the developers out there when they are creating their application, but it's also a message to the sysadmins out there and the people managing systems. If you can get involved in the conversation earlier at the early stages of application development, this is one of the things you're going to have to push for the hardest.
And I think you're right, Chris. That is key. Maybe early on in your process, you're like, yeah, we'll just store the passwords in plain text. No, don't do it. There's no reason to do it. Use a cryptographically strong hash. So no, not just MD5, like something designed for this. Things like SHA-3, scrypt, or bcrypt. And of course, the hash should be salted with a value unique to that specific login credentials.
Something that you're going to agree with me on, absolutely, because it's long-standing advice of the TechSNAP program, is design your system assuming eventually it will be compromised. Because if you build anything that matters, it will eventually get compromised.
Exactly. We've seen a number of these. One that comes to my mind right now is some of the breaches over at LastPass, where they did have some hackers get in.
Yeah.
Some data was stolen, but because they followed these best practices,
pretty minimal damage.
Yeah, exactly.
Good point. Also, make sure you're asking questions like, what can we do to mitigate the potential for damage in the event of a leak or in the event of a breach? So think beyond the compromise and think about what happens once you've been compromised.
Yeah, this is a great opportunity to have a run list prepared. If you run any scale of service, this will probably happen to you at one time or another. So don't be surprised by it. Have procedures in place so that when that dark day happens, you're prepared.
And if you're building something that's on the LAN for an internal company, consider the threat of somebody that's already authenticated to your network and privilege escalation as well. What are your thoughts, Wes, on using third-party identity providers?
Yeah, often that can be one of the more complicated things to get right, building any type of service. And so if the service that you're providing already relies on people, online integration, it's an online account, then using the systems Google, Facebook, and Twitter have already set up can oftentimes be a reasonable compromise.
In my past experience, one of the things that we decided to do for our intranet authentication, and when you authenticated to the intranet, you would get access to HR documents. Depending on your group memberships, you would get access to different links.
Right.
And we spent a considerable amount of time back in the day tying in the intranet authentication with their Active Directory account credentials, which wasn't as easy back in the day, but we wanted just one single sign-on. We could change their password in Active Directory, and it would change their password on the intranet. We could change their group membership in Active Directory, and it changes what they saw on the intranet. Really nice.
Right. And super handy when it comes, maybe that employee's let go. You really need to deactivate the account. Not having to go do it in 6 different places is a big win.
Something we didn't get right back in the day, but I really wish we could have solved, was separating the concept of user identity and user accounts.
Yeah. I mean, your users are not an email address and they're not a phone number. All of these things can change. How many sites have you been to where you've put in your email and you can't change it? That's your identity forever, even if you don't have access to that email anymore.
Right, or the other super common one is name changes. I want to change my last name. Things like that come up very frequently.
So really, it's important to model your users as the culmination of all of their unique personalized data and experience within their service, because that's how they think of themselves, and any other model is just going to be confusing. In particular, a well-designed user management system has low coupling, right? So that you can change some of these identifiers or attributes of a profile and have that be consistent within the system and work with all the other components.
Interesting. Yeah, and I suppose if most authentication systems have like a unique ID number for a user, that's the actual thing that's being tracked. That makes that a lot easier. So consider that when you're designing your system as well.
Yeah, I think that's a key takeaway here is that, you may use your email to sign in, but maybe you also use Twitter's authentication to sign in, right? And neither of those is what identifies you to the backend systems. It's a holistic view of a profile. You have an account, and it's not, maybe there is some ID somewhere in a database that identifies you, but it's not the credentials you use to access the service.
Sure enough. Okay. I don't think our audience needs to be told this, but I am surprised still. In 2018, when I go to sign up for certain services, they tell me my password is too complex. What's going on here? This has to be the way they're storing the data in their database.
Yeah, that is almost always a sign of, well, maybe just laziness or a poorly designed
red
system.
flag for me.
Yeah, right. I try to run away from those. Unfortunately, oftentimes those are the banking institutions or other services that you just have to have as a matter of everyday life. So I hope more developers heed Google's advice here because it's really important to get right.
If they want a password made of emojis, white space, and escape characters, let them do it. ixsystems.com/TechSNAP. iX Systems builds reliable systems that are custom built with your specific needs and requests in mind. White glove service from beginning to end, and they're the leaders in open source technology that powers all of these systems today. And if you're serious about storage, check out their TrueNAS product line. They're also the folks behind FreeNAS, and they're the experts in ZFS. ixsystems.com/TechSNAP. That's the landing page to support the show and learn more. And then head over to their blog. They posted just a few days ago about TrueNAS and video editing. TrueNAS makes the cut with Avid Editing, and it's a fascinating write-up on how M&E Editing uses TrueNAS on the back end to centralize the storage for their video editing shop. Check them out, ixsystems.com/TechSNAP. From single FreeNAS minis up to entire cloud rack solutions with incredible compute and storage power. Your imagination is the only limitation, and the price is going to blow you away. ixsystems.com/TechSNAP. Okay, that's all the basic normal stuff. Now let's talk about something that's a little beyond the normal.
Yeah, and that's Google's Beyond Corp, a new approach to network security which treats their internal network as the untrusted, insecure internet.
So just assume everything is insecure. Even the things on the LAN, it's all insecure.
Right.
And they've been doing this for about a year now.
Now, Chris, you're probably familiar with the conventional perimeter security model, right? So you have some firewalls, maybe you have a VPN set up so if, your remote employees can access the services. But generally in those setups, now, of course, sometimes there's gates between QA and prod and little details there. But if you get access to your development machine, that's game over. I mean, you can access pretty much anything.
If I fire up my VPN, I'm on the LAN.
Exactly. And you're assumed to be trusted, right? So it's this very simple model of those out there we don't trust, but if you're inside, if you have access to internal resources, generally have at it.
In fact, I would say it's that very model is what attackers can exploit. When you have somebody that gets on your network, that's what they leverage, is that access to the flat LAN.
Exactly. We talk about that a lot. Things like island hopping, exploit chaining, all of these are mechanisms to get some level of access which you can use to get to your eventual target.
So they consider both internal and external networks to be completely untrusted. So are they just building firewalls between everything? I mean, how are they doing this?
All right. Well, it's a complicated setup. Obviously, this is Google, and they've published a lot of research here, and I think that's really great. Not just anyone can implement these sorts of things. There's a lot of custom work, things you have to tailor for your own model. So let's dive in. The first part of it is having a basic inventory of devices. So instead of just, this computer's on the LAN, they want to know more about what is this machine? Is it patched? So the first step is just know where everything is, how it's provisioned, and start keeping records. This enables what they call tiered access for both devices and resources, right? So whether you're on your work-provided laptop or your home machine or the Android phone in your pocket, that device needs to have the same level or higher of trustworthiness to access trustworthy resources. So, if you just want to view some form that's open to everyone, have at it. But if you need to go get secure HR documents, then you need to be using a device that's authorized for that level. Really, the idea here is, especially when you're Google scale, but really these days, security is becoming so important. It could be at any business. It may be one thing to have your employees looking at sensitive personal information or other details of customers while they're on a trusted, updated, patched work laptop. But just because they VPN from their home machine, that does not mean they should have the same level of access.
Okay, so you have to go through and inventory your devices, figure out their patch level and their software versions and their trustworthiness, but you've also got to do the same to your data. You have to figure out what data is easily accessible by people that are on the remote devices and what data needs to be even more protected. I mean, that's a massive overhaul.
Yes, it is. And that's a huge part of this system, is that by leveraging all of this data collection, they can make intelligent choices. So it is a lot more work, right? It's not just setting up firewall policies, denying by default, and setting up a VPN. They actually have multiple types of data. So they have both observed and prescribed. Observed data is things like the last time a security scan was performed on a device, all the synced policies, let's say for an Active Directory machine, as well as stuff like OS version and patch level.
So this is data about the devices themselves.
Yeah, exactly.
Interesting.
So it would be a different security level if you're on a machine unpatched for Spectre versus patched for Spectre.
So they're watching these systems like they watch users of the Google apps.
Exactly. And then, of course, too, there's some prescribed data. And this is the stuff that, IT operations is manually assigning. So things like the owner of the device, at least in their systems, what users and groups are on the device, DNS, DHCP assignments, and, maybe explicit access to certain VLANs.
So say I'm a Google employee. What do I have to do to be considered a trusted user and a trusted device?
Yeah, this is where it gets a little more practical, right? So they're doing all this data collection, and here is where they can really put it to work, right? So you're trying to access some resource, and then intelligent decisions can be made. So in particular, if you're trying to get like a high level of trust, you're trying to access sensitive, private, corporate information.
Yeah, I've got a memo. My name is James. I want to spread it around.
Right, exactly. So 1, be encrypted. 2, successfully execute all management and configuration agents, right? So whatever is supposed to be run on your type of device, that needs to be run and have run recently. Then 3, of course, have all of your recent OS security patches installed, and have a consistent state of data from all input sources. So that's a key one right there is if you have, inconsistent data, rapidly changing data, that's another sign that you shouldn't be trusted.
It's a red flag. Something's going on over there. So the consistency of your machines and their trustworthy state is also taken into consideration.
Exactly. Now, one interesting note here is Google's been saying publicly that the stage fright vulnerabilities that have been discussed in Android, even on this show, not a big deal, but the company itself has been banning these devices using this system.
Oh, it's no big deal, except for we don't want any of that here on our network.
But it does, say what you will about how they're communicating, it does show the strength of this system in that, you don't have to blacklist a whole class of devices. You can do it at a fine-grained level.
That is pretty cool.
Now, of course, you're thinking, well, there's got to be some exceptions, right? None of this works perfectly. This is the real world here. And that's certainly true. So sometimes Google has, they have policies in place where they can override certain classes of devices. Maybe, there's a new device that they just haven't been able to assess yet or assign policies that they'll just blacklist. Or you just have a new device that you're testing and it needs access to the lab. So they do have some mechanisms here to just make it work in the real world.
As somebody who has lived the IT support life for many years, I could see a scenario where big important executive comes to your campus for the first time ever for big important meeting and their device cannot get on the network.
Yes, absolutely. That has been one of Google's biggest challenges when getting this all deployed correctly, especially, as we've been talking about, this all hinges on their active analysis of data. And so, maybe his phone, maybe he was on the plane for long hours, it hasn't checked in, it's missing just one level of patches. All of those things can cause unintentional access loss. And that, you're just trying to get work done from the employee's perspective. That can be devastating.
I guess that's also a chance for them to improve the system, and they just keep iterating on it. In a sense, they're dogfooding their own monitoring systems. I suppose that's a good thing. There must be an escape hatch here, though. If something goes really, really wrong, there must still be a few chosen devices that still have access, no?
Yes. So now that they've sort of made the transition over to BeyondCorp for most of their services, they really have to plan for disaster recovery. And, you can't have a system where everyone's locked out. Google provides services to so many companies, especially as we were just talking about some of their cloud services, which are companies not even internal to Google. They do have some disaster recovery things. In particular, there's an extremely small subset of privileged maintainers. Obviously, names are not included here. They have privileged levels of access so that, really, these are like the core administrators of the system. They have keys that can get them in and enable things. Also, in case of an emergency, they do have the ability to push more fine-grained changes. So, hey, it's an emergency. Yes, that device isn't normally trusted, but you need to access it right now. Done.
My way out there thinking is this may be the way a lot of people have to design in the future if our IPv6 world ever comes to a true reality.
I think you're right. And so one thing that we haven't really talked about, but I also think is key, is that in this model, they don't have to maintain a bunch of complicated VPNs. They can publish services, quote unquote, publicly,
right,
but only allow access. When you view the intranet and the internet as one thing,
right,
in many ways, it's simpler.
It is. And it's also kind of a mind bender when you think there is no LAN to compromise. That really puts everything I know about penetrating a network up on its head.
Exactly.
TechSNAP.ting.com. Ting is mobile that makes sense. Big thank you to Ting for sponsoring the TechSNAP program for so long, and it's been a great fit for our audience. It's pay for what you use wireless, and they have 2 networks to choose from, CDMA and GSM. $6 a month for the line, and then you pay for your minutes, your messages, and your megabytes. A fair price for however much you talk, text, and data you use. Nationwide coverage, no contracts, and no early termination fees, and no secret agreements, quote unquote, that they have in those other duopoly carriers. You can have full control over your account. You can see your usage at a glance. You can set alerts. You can set thresholds. You can just turn stuff off, turn stuff on. And of course, with CDMA and GSM device support, there's a whole metric ton of devices you can bring to the Ting network. TechSNAP.ting.com. In fact, I got a little tip for you. If you're looking for a get-around-town Android device, it's going to still get updates. It's got a nice battery, 5,000 milliamp battery, and a 13-megapixel camera with 2 gigs of RAM. If you go to TechSNAP.ting.com, directly from Ting, you can get the Moto E4 Plus for $174. No contract, nor the termination fee, and it does CDMA or GSM. That's an incredible buy. Moto E4 Plus, what a great deal. $174, no contract. You buy it, you pay month to month, just pay for what you use. If you're on Wi-Fi, download your podcast, pin your music. You will be blown away with the savings from Ting. TechSNAP.ting.com. We're out of space, we're out of time, and most importantly, at 95% capacity, our pool had too much.
There's only one thing to do.
We could strap on some external storage array and go super cheap, or we could do one step better. New hardware.
It's Operation FreeNAS Rescue.
Like many of you, Jupiter Broadcasting is constantly fighting the storage monster. Always running tight on space here at the network, and in episode 348, we made our first initial stab at rectifying the situation, taking care of our server neglect, and getting our FreeNAS system up to date. But we didn't solve the core problem of storage. Today, it's phase 2 of this project.
The last time around, we got the software situation sorted, but now it's time for the hardware.
After hemming and hawing about how I wanted to address this problem, I even considered just plugging in an eSATA array to my existing FreeNAS Mini. I realized it was time to upgrade the entire rig. I purchased a used Supermicro server, moved over the FreeNAS internal header drive that has FreeNAS pre-installed on it from iX Systems, slid in the new disks, and hit the power button. And now we just wait for the controllers and the network cards to wake up.
We got some post!
It's so exciting, Wes. 2 Xeons, 2.2 gigahertz. It's got a separate SAS controller, which is nice too. Down the road we might use that. It's got open SATA ports and open USB.
Yeah, plenty. 2 NICs.
4 NICs.
4 NICs.
There we go. So there's a hard drive. Just got detected by the LSI controller. All right, so now we're sitting pretty. Now what we don't know is going to happen is if it'll boot off of the FreeNAS installation USB media. I don't think it will by default. I think we're going to have to go change BIOS settings.
It booted successfully, saw the drives. Now it's time to create our pool.
So we're going from 4 drive bays to 12 drive bays.
Yeah!
Yeah, that's nice.
You know, there's something about the FreeBSD kernel booting up. I don't know if it's the font or what, but I really like it.
I know. It's just fun watching all that stuff go by. I like the expandability, so there's multiple PCI Express slots open. There's tons of open slots for RAM. So once RAM prices come down, I'm going to totally upgrade that. And then, once all is said and done, right now we have 8 open drive bays, and when all is said and done, we'll have 4 drive bays left open. I can put huge drives in there.
It's trying to mount the pool that doesn't exist.
All right, so I expect this not to be great because...
Oh, maybe not, unless it's actually trying to mount from the... Okay, no, we're still in the initial
Okay,
boot up.
good. Okay, so it's mounting the local file system there. Okay, well, this is good. This is just detecting the new CPUs there.
Now, see, I should have realized this, but what I didn't see is that it's actually ZFS on the USB drive, too.
Oh, that is awesome. All right, so it's going for its IP. I have not statically assigned an address to this yet.
Okay, 110. We've got it.
So one of the NICs does seem to be active and has a network address.
Dual NICs. That's 4 NICs, right? That's beautiful.
So what our thoughts here is we get this up, we create a new ZFS pool with the 4 5 terabyte drives that we've added, maybe two sets of mirrors, and then we validate the configuration. Then we import the existing data either by formatting those drives and doing a ZFS import, or by just moving the disk directly. We haven't decided yet, so we thought the first step would be to sanitize the new server configuration, get the FreeNAS installation up and running, set up the new drives, and then I have the option to migrate the data if I want, or move the disk directly, whatever works better.
It seems like with all this configurability, it's like a 5-year server.
There we go. So we're up, it's running. The same FreeNAS config that I've had for years now is now running on this new hardware.
Beautiful.
Man. Well, even as a Linux enthusiast, it's hard to beat this. Let's take a look here. Let's see what we've got. Okay, I'm bringing it up in the webpage now. Root. Do you remember what we set the password to?
A time-old sysadmin question.
Yep.
I don't remember, but it looks like you do.
I got it, Wes. All right, so we've got one critical light. Let's take a look. I bet this is about the pool that's missing. What do you say? Yeah, there you go. Volume buttermere is unknown. All right, that's totally expected. It does seem like it's working, though. Like, obviously we have network communication. I expected that to actually be the hardest part. Different MAC addresses, I thought it would just shit the bed. View disks. There we go. It sees them. All right. Okay. Yeah. Okay, so now if we could... what do you think about creating 2 sets of mirrors and then putting that into a pool?
Let's do it. Snap to it.
Snap Spot.
Yep.
All right, we're going to name it Snap Spot.
Now, personally, this has been an interesting experience just because I'm not actually that familiar with the FreeNAS system. I've used them here as there. I've certainly attached stores, and I've used the underlying FreeBSD.
Yeah, what's cool is that look how the interface is actually suggesting automatically to set the 2 up in mirrors. That was what we were thinking, but that's just what the UI is doing. All right, I'm clicking Add Volume.
Oh, yeah. And then over here on the console, we've got, Geom.
Yeah, we have the monitor hooked up to the console so we can see the output. And on the output, there it goes. So this used Super Micro chassis is very similar to the systems that IX Systems build. And after talking with Alan, it seemed like the perfect used solution. I got this off of eBay. The only thing I would really change about it is I would add more RAM. I think that's going to be our biggest problem. And I'm just kind of waiting for RAM prices to come down. It actually is only configured with 4 gigs of RAM. I thought I had 8, but reviewing the specs, I realized it only had 4. So that's one thing that I'm majorly concerned about. But since we're just doing 4 disks right now, it should
not be totally sufficient.
Yeah, it's not the full storage setup yet. I think the timing will work out perfect. We'll validate the setup. We'll be able to purchase RAM, install the RAM, and then add the rest of the storage. But in total, even after I buy the RAM, I'm probably only $500 to $600 in, probably $650 in.
And I'm really impressed. It's clean, it's beautiful, and I mean, you wouldn't want it at your desk, but it's pretty quiet.
It is pretty quiet, actually. It is really clean. Like, they've gone through and they've just cleaned up all of the dust. It's in pretty great shape. I'm excited about the flexibility this is going to give us, as long as this pool gets created. You know, I wasn't really sure how this would go. I thought it's a new controller, it's 4 new network cards with different MAC addresses. This could blow up in my face. But it was rock solid.
There were really any number of ways for this to not work, and there were obviously tons of little problems along the way, but overall, it's been surprisingly rock solid.
This gives me an intense confidence in FreeNAS as my base platform. The fact that we could move this from a FreeNAS Mini that's using Atom processors to a super micro server with dual Xeons and an LSI controller and Intel Gigabit network adapters, and it didn't even complain, is remarkable. It gives me big confidence that I can keep moving this forward if the hardware ever fails on me. And with now a solid hardware base that has redundant dual power supplies, plenty of network, and plenty of drive expansion, I've got a good solid hardware base and a good solid software base. And I'm going to spin down the Jupiter Broadcasting virtual server and move some of that infrastructure onto our FreeNAS. We'll be adding additional storage, all of which will be future content as we do it. We're taking a nice, slow, staged migration approach.
Well, you know, I mean, this is a production environment. We got to do things carefully. It really does strike me, though, that how long would this have taken if we were to, install FreeBSD ourselves, get everything configured, build all the pools, consult a bunch of ZFS documentation to make sure we were getting it right. But this, I mean, we took our time, but the formatting of FreeNAS as an appliance, when it meets your needs, which it does for us here, it's just beautiful.
Yeah, I mean, this is stage 2 of what seems to be a 3-stage project for us because we're taking this piece by piece. But I got to say, I was pretty impressed by the software defaults. We had already determined that we were going to take these 4 drives and do 2 mirrors and then bring that into one pool. But that's what the GUI just recommended to us. And then the other thing it recommended that we hadn't really even thought about yet is it automatically turned on LZ4 compression.
It's
great.
Really that sweet spot between all the configurability you could want or need as an administrator and really sane defaults.
Yeah, after this passes our stress test, which we're going to do after the episode, we move over the remaining disks, spin up the applications I need, and we're set for years. DigitalOcean.com. In fact, go to do.co/snap and get everything I'm about to tell you ready to go. DigitalOcean is a simple cloud hosting provider dedicated to offering the most intuitive and easy way for you to spin up systems super fast on their crazy great infrastructure all over the world. Everything is SSD backed, 40 gigabit connections coming into the hypervisors, 8 data centers all over the world, and an interface to manage it that'll blow you away. And then, to make things even better, they have an elegant API that gives you access to everything. Pre-built, ready-to-go applications, the entire stack, from the OS up to the web app, or just the base system. You choose what you want to deploy and get it started in seconds. DigitalOcean's been making a lot of improvements. They have their standard droplets. We talk about those all the time. They've just essentially gotten better recently. More resources for the same price. It's just incredibly competitive. They now have flexible droplets. This is great. It's a new plan. You can mix and match resources that are the most appropriate for your application. And then they got the big boys, the CPU-optimized droplets. Oh man, these things are incredibly high performant. They also have systems with just hundreds of gigs of RAM, whatever your use case is. From a $5 a month system, my favorite, the 3 cents an hour system, or now the new flexible mix and match droplets. DigitalOcean.com, use our promo code SNAPOcean, or even easier, do.co/snap. Thanks for visiting TechSNAP.systems/contact and sending in your questions or your show feedback. And Dax sent in a question. He writes, Wes, your introduction to configuration management couldn't have come at a better time for me. I'm just at the beginning of needing some sort of management project for what I'm working on. My project consists of 100 plus Raspberry Pis distributed across 60 different locations. Each location is behind a NAT, and I won't allow the public IP of each location, and it might also change over time. I do have the ability to host my management server at a place where I can assign a static IP address via NAT. Dax has also done a lot of research. He's been trying out Puppet and Chef, Ansible, SaltStack, and others. But the problem with some of these, like Ansible and SaltStack, is that they want to create an SSH connection into the system they're managing. And since his Pis are behind NAT, that doesn't work. That means the remaining options are the pull style of configuration management, but it also appears they don't always handle NAT very well. Additionally, Puppet has a limit of the number of nodes that can be managed for free. Anywho, I'm hoping you can point me in the right direction of which management system will work best for me, and I hope you can provide me with a link to documentation that will help me configure this setup, because yikes. By the way, love the Jupiter Broadcasting. I'm glad to see you and Chris and the others keeping up the good fight. I listen to all your shows, and I let the sponsors know I heard about them from you. Thank you very much, Dax. So what do you think, Wes?
One, just thank you. This is wonderful feedback. We really couldn't ask for better engagement, and it's one of the most fun parts of the show, really.
Mm-hmm.
Okay, so just to start with, it is definitely a journey, and it's not always easy. In particular, a lot of these solutions are also companies making them. So while they mostly do offer mostly full-featured open source versions, you do have to wade through, especially in their documentation, a lot of things that will either be enterprise only, or we'll just keep trying to mention the enterprise version of it. So that's just a disclaimer up front. Whatever you're working on sounds very interesting. I love the use of all the Pis, but I can see how NAT and disparate networks can make this pretty difficult. Well, starting with CF Engine, unless you have a strong reason to use it, I'm not a huge personal fan. So if it works for you, that's great, and configuration management's awesome. But I would look at some of the others. Ansible, you're right, would require, an SSH connection from wherever you have your Ansible config stored, and that could be difficult if you don't have, careful firewall policies already set up, and you may not even have the ability to do that in all of these locations. Now, you can run Ansible without that. One option people do is they have just a Git repo somewhere. You could have it as a private GitHub repo or host it on your own, somewhere in the cloud. Lots of options there.
A little complicated, but definitely doable.
Right. And so then what happens is you set up a cron job or systemd timer or whatever have you. It pulls down the Git, runs Ansible locally. The other downside there is you have to make sure that it happens, right? So you have to put some monitoring or other things to make sure that those runs are actually happening. So maybe not Ansible. SaltStack does have somewhat of a push architecture, but it's a lot different than Ansible. In particular, it's faster, and part of that relies on its use of 0MQ. So you'll have a salt master, and then the minions actually initiate a 0MQ connection. So as long as you have the master with a public IP not behind a NAT, then the salt minions should be just fine, because it works almost, if you haven't used an MQ, things like RabbitMQ, ActiveMQ, 0MQ, you can maybe think of it something like a WebSocket, where there's a consistent connection established between the two servers or between all of your minions and the master. And once that's open, they've already got the connection tracking, the NAT stuff is handled, and then the master can actually send events through the MQ bus, the minions receive it, and then execute things. So I think SaltStack is still worth looking at. In particular, I like that it's Python-based, and it's, at least for some configurations, simpler than Puppet and Chef. So go check that out. I'm not the most familiar with SaltStack, but I do think it should be able to be configured to work in your situation. There is definitely some confusion, but based on my research, it does look like Puppet does not have a limit in its purely open source version. Now, again, probably some of the docs and other things have guides to install from whatever their enterprise repos are, so you may need to go to the actual GitHub repo to check that out. In particular, I know that Chef, the open source version, it doesn't have some of their more DevOps automation products that they sell only at the premium level, but it is fully featured. The Chef client is open source, there's debs available and other things, and the Chef server is open source. In particular with Chef, the Chef server is pretty easy to set up because they actually have a cookbook for it. So you can go install the Chef client on your future Chef server, download the Chef cookbook for the Chef server, run it, and have it mostly just work. And the advantages there with something like Puppet and Chef is they have a lot of these things built in to check on like the status of the node. When was the last time it checked in with the server? What was the status of its last run? Now, without knowing more about what you're actually going to run on these pies, I would say looking at SaltStack, Chef, or Puppet, go take a look at some example in Chef, their cookbooks, or go look at example configurations and see, one, how do you like the style they're written in? Does that seem like something familiar? If you're more familiar with Ruby, then maybe Chef or possibly Puppet are good fits. And go look for solutions. A huge amount of the power of some of these systems is open source contributions, right? So in Chef, there's a ton of cookbooks that you can use to go install common configurations. So go see which of these has better support for the things that you're trying to install and get configured. Maybe go look at a couple examples, see how it fits your style, and then spin up a couple machines, play with a couple pies, install them, get it going. Maybe pick one or two, test those out. It pays to get it right and to get a system, because at some point these are going to be running on all your nodes and you're going to have to live with it.
And just as a bit of follow-up to last week's episode, you may have noticed that Wes and I are not huge WordPress fans. We're sort of begrudging users of it. If you walk down the streets of Seattle talking about WordPress, Wes may or may not yell at you. That may or may not actually be a thing. But I did notice a story out of Google this week that may be improving things. We'll see. It seems that Google is working upstream with WordPress to essentially improve performance of WordPress. I think this is more of an AMP play than anything else, so I'm a little mediocre on that. But it does seem to be some real actual code may get developed here. They have a position open at Google that seems like the primary focus of this job will be to contribute upstream to WordPress. So WordPress may be getting a bit of a kick in the butt very soon.
Yeah, one of the reasons I'm not super fond of it is often you get pretty gross output, right? It's really designed for the content creator and not on, no one's doing a once over on this generated HTML. So it's often unoptimized or not properly optimized. In that sense, this is interesting. And I hope that it's not just an AMP plugin. I hope that there's some changes made to core, some other functionality added. That I would love to see. Otherwise, I think you're right that there's a risk here that basically they've just figured out a way to make WordPress work with AMP and it doesn't benefit anyone else.
Yeah, we'll see where it goes. maybe something good. Let us know what you think about anything that we've covered on the show, or if you have any questions for us that you'd like us to try to answer, techsnap.systems/contact. Fill it out there and send it in. It goes right into our inbox. The nice thing about using that contact form is that on the back end, I formatted it so that way I can just do a search query right before the show and get all of those emails in one place. We also have the subreddit, and you can always contribute questions and feedback there. techsnap.reddit.com, and again, techsnap.systems/contact.
Thank you very much for joining us today. That brings us to the end of the TechSNAP program, but don't fear, you can head over to techsnap.systems to find more. In particular, you can find everything we've talked about here today at techsnap.systems/355.
Yeah, and while you're there, also /RSS for the RSS feed and /subscribe for all of the buttons you can click to subscribe in your favorite podcast player. And if you like what we're doing here, consider supporting the whole network at patreon.com/JupiterSignal. And you can follow the network at JupiterSignal on Twitter. Thanks so much for joining us. We'll see you next week.
Goodbye.